In this section, we're going to learn how to solve absolute value inequalities. Our objective is that you're going to be able to solve absolute value inequalities. You can graph absolute value inequalities, and you can distinguish between which absolute value inequality is an and or an or inequality. This is going to be putting in pretty much all the sections we've learned so far together. We'll be pulling in the and the or inequalities from our component inequalities, section 1.3, and then we'll be using what we learned in section 1.4 about absolute value equations. So how does this relate? So remember, in absolute value equations, we would have two solutions. When we had the absolute value sign isolated, we can do our 2, where we had it equal the positive distance, and then we had it equal the negative distance. So in this case, x plus 7 will equal 9, x plus 7 will equal negative 9, and then we'd solve each and get our 2 solutions. Remember, for compound inequalities, we had an or and an and. So an or, when we graphed it, they went outwards. And then our and, we went inwards, like so. And putting these together, we'll get our absolute value inequalities. So an and inequality, there's kind of two situations that will come about that will give us our and inequality. One is when it's less than a positive distance, when the absolute value sign is less than, because we will still do our 2 solutions. We'll have x, we keep 1 the same, because it's our positive distance. And then we have to do our negative distance, and recall from inequalities, anytime you change the sign, we have to flip the inequality sign. So instead of less than, it's greater than. So if I would graph this, we would have our 2 values, 7 and negative 7. They both have an open circle, and since I'm on greater than negative 7 and less than 7, they would go in between, which is our and inequality. So I can write, and you will have to write your final answer, as a compound and inequality. So the bottom is what you would have as your final answer. On this one, x is greater than a negative number, and you might be thinking to yourself, wait, Mrs. Seyfried, you told us absolute value signs can't be negative, which is true, but since we're representing a set of numbers, everything greater than negative 7, there are some positive numbers greater than negative 7, so there are solutions to this equation. So since it's isolated, we're still going to do our 2. So the absolute value is greater than negative 7. And then we are going to flip our sign, and since it's negative here, we have to change the sign to a positive. X is less than 7. So then when I graph this, we're going to have negative 7 and 7, and we're actually going to be in between these 2 values. So I can write this as a compound inequality, like so. So again, the graph and then the bottom compound inequality, the and inequality, are my 2 final answers. So an or inequality is when it's greater than a positive number. So here, we're going to have x is greater than 7, and x is less than negative 7. So when I graph this, I get negative 7 and 7, open circles, and since I'm greater than 7 and less than negative 7, this is or, and very easily, because or inequalities, all it is an or in between, you can just put an or in between the 2 inequalities you finished up with, if they're close by to each other. So just kind of recap, when it's less than a positive, it's and. When it's greater than a positive, it is or. And when it's greater than a negative 7, it is and. If we have less than a negative number, well, that would be a no solution there, but we're not going to be dealing with any of those in this section. Another thing, if you don't want to memorize this, that is fine. Wait till you get to your graph, and then you can examine it there and go, okay, that's an and inequality, write it as an and. If you got a situation like this, you can write it as an or inequality. So let's do a few examples. So in A, I have the absolute value of D is less than 3, so it's less than a positive. So from the previous slide, we know that is and. I can do my 2 equations, because we have 2 distances. We have positive 3, and then we have negative 3. We change the sign, so I have to flip my inequality sign. So I can graph negative 3 and 3. They both are not equal to. So we have open circles, and it's in between. Again, I cannot write that as my final answer. This is my final graph, but since it's an inequality, I need to write it as an and compound inequality. So the next two, the absolute value sign is isolated. There's nothing on its side of the inequality. So I can go right into my two equations. So I have t minus 4 is less than or equal to 7. And then I have t minus 4. I need a negative 7. So instead of less than or equal to, we now have greater than or equal to. We can add 4, and I'm just going to do both equations simultaneously because you probably have noticed so far it's the same operations on both equations. So t is less than or equal to 11. And then t is greater than or equal to negative 3. Again, don't be worried about negative answers. That's okay for inequalities. We already talked about the situation, which we're not going to have come up when we're solving inequalities. So, alright, so we have closed circles because they are equal to and greater than negative 3 and less than 11. So that is an and inequality. So my final answer, t and 11. So on C, notice we're greater than a positive number, so this should turn out to be an or inequality. Again, if you don't recognize it right away, that is no problem. Just wait until you get to your graph. So I have 2x minus 7 is greater than or equal to the positive distance, and 2x minus 7 is less than or equal to the negative distance. We can add 7 to both sides, and I'm going to do both equations simultaneously. 2x is greater than or equal to 16. And 2x is less than or equal to negative 2. Divide by 2. X is greater than or equal to 8. Divide by 2. X is less than or equal to negative 1. So graphing it, negative 1, you have 8. Close circles on both. And that one is less than negative 1, and then x is greater than 8. This is or inequality, so if you have them next to each other, I can just write an or in between. If they're not next to each other, then you're probably going to have to write them again to make it a proper compound inequality. So on D and E, notice they are no longer isolated, so we need to isolate the absolute value sign. So on this one I have a plus 4, so we need to move that first before we write our two equations. Otherwise we do not have the correct distance for the absolute value. Again, don't be alarmed by the negative because it's greater than negative 2, so there are values that would make this true. So I have x plus 1. It's greater than negative 2. And x plus 1, so it's negative 2, so the opposite of negative 2 is positive 2. And I still need to flip the sign because I changed the sign, or I changed the value here. So I minus negative 1, so x is greater than negative 3, minus 1, and x is less than 1. So I have negative 3 in my number line, and 1. If we did this correctly, it should come out to be an and inequality, which were greater than negative 3 and less than 1, which it is. And you have to write it as your compound and inequality as your final answer. So in E, we actually have two things that need to move. We have a minus 5 and a times by 2. So I'm going to add 5. So I have 2 times the absolute value of x minus 3 is less than or equal to 12. Divide by 2, since it's multiplying by 2, just doing my inverse operations. X minus 3 is less than or equal to 6. Now I can do my two equations. X minus 3 is less than or equal to 6. And x minus 3 is greater than or equal to the negative distance of negative 6. We're going to add 3, x is less than or equal to 9, add 3, add 3, x is greater than or equal to negative 3. Graphing it, we should have negative 3, 9, close circles because they're equal to, and we're less than 9 and greater than 3, so that is and. So again, do not stop there. At the bottom, I'm going to write it as my compound and inequality. We have x in the middle and 9. That's my final answer. Alright, so just to review, again, there's nothing a whole lot new with this section. They're just similar to absolute value equations and compound inequalities, just putting those two concepts together. The two inequalities when solved make a compound inequality, so either and or. So remember on your graph, the and is inwards, it's your range, or is outwards. And then remember to flip the sign when multiplying divided by a negative number, which is why on the second distance, the negative distance, we have to flip the sign. Alright, so this concludes video 1.5, absolute value inequalities. One last reminder to make sure you do your reflections so you do get credit for watching this video.